Okay, so in this video clip, we're going to take a look at the quantity theory of money, which is sort of important, and it's important when we're trying to understand, for instance, why Bitcoin has limited the number of Bitcoins it has programmed into its algorithms that it will allow to be created. And in part, the idea is if you limit the supply of something, then the price will be stable, right? And again, that's an old idea that has been developed through time by an array of different contributors. Friedman and Anna Schwartz in recent years are kind of two figures that are very significant in the field of monetary economics, and they would have had strong perspectives around how do you control the money supply and what that means then for controlling inflation. And they would have made arguments that you should control money supply very tightly so that you can control inflation. The thinking would be that if for instance, we were to set it up as a sort of a relationship, that the quantity theory might be summarized. If we take the money supply multiplied by the velocity, or the number of times the money flows through the economy, and that would be equal to the price level multiplied by what's being produced in the economy. So if the velocity of money was quite stable and the output didn't grow very significantly, then the two free variables here are money and prices. And the only thing that would affect the price level or inflation would be the quantity of money. So if money increases in supply, then, and the other variables, the output of the economy and the velocity are relatively constant, then the major impact will be felt here on the price level and inflation. So to control inflation, then this obviously creates, a very simple policy prescription. In a sense, you control money. To control inflation, inevitably it involves controlling the money supply. And so then staking out a relationship between the two, then something that could be of interest to us here. And it's also relevant in a modern era with the Bitcoin. Part of the Bitcoin framework set up by in the white paper was that the supply of Bitcoin would be limited, and that would be seen then as a hedge against inflation, right? So these ideas are very pervasive, and we see them manifesting in many forms and go back a long way. We're going back here to the 1500s, to Copernicus and to John Locke, David Hume, Jean Baudin, and more recently then Friedman and Schwartz. One name left out here I would have put in here is Richard Cantillon, who also pointed to the quantity theory, but Cantillon also said money mainly is neutral, but can have non-neutral effects. If you increase the supply of money, you actually do produce winners and losers in the process. So the first to touch that money very often become winners in that process. It all depends on how it pans out. So it's not a completely neutral thing. You can affect outcomes, but in terms of magicking up more, a bigger pizza, if you think of money as the way we divide up, the pizza, we can make more slices on the same pizza. Doesn't mean we're creating more pizza, but the way we cut up the pizza can be very important. So this is something that Cantillon pointed out, and I think is worth us noting as well. Also, if you're a student and you're considering doing some kind of econometrics, I wouldn't follow the approach I take here. This is a very blunt, kind of throw it together approach, and I will try to run a regression, OLS regression, regressing money supply onto the price level, but I don't take account of serial correlation in my data. I don't take account of if the variables are stationary, if the variables are co-integrated or not. So this is not something you should put into your dissertation, or if you do, it requires more refinement. Now, where it could be useful is just how would you, just to see a little bit the technology, how you would load in data, how we would scrape data using this very powerful pandas reader. So we do a pip install here in this Google Colab, which is a Python notebook, and we install in pandas reader, data reader, which allows us to pull in through APIs data from directly from the internet. And the pandas are part of the suite of libraries available in Python that allows to do data manipulation, data transformation. Datetime allows us to keep a clock, if you like, on the index of dates. Matplotlib is for visualization and graphing, and NumPy is for a sort of optimized way of doing mathematical operations in Python. We load in, we run then, or import in the pandas data reader. We'll see that will be important here in a moment. Quantity theory, a simple definition here, or relatively intuitive definition provided by Lucas, 1980 Nobel laureate. Given a change in the rate of change in the quantity of money induces an equal change in the rate of inflation, right? So that's it at its simplest. But I think Lucas did note in 2010 that direct relationship between money and price level sort of broke down. Part of that could have been because of the banking crisis. Money was printed, or there was quantitative easing. There was an increase in money. We didn't see that in consumer prices increasing. Maybe this is something that people now are more aware of, that during the 2008 to 10, 12 period, when money supply was ramped up in the US very dramatically by the Federal Reserve, we didn't see any evidence of an increase in the consumer prices, but in asset prices, we have seen fairly dramatic increase in the value of property, in the stock price indices, S&P 500 and so on. But that's another day's work. So purely in terms of the going down a Python route here, trying to scrape in data, what we have is I want to pull in M2, money supply data, directly from the Federal Reserve of St. Louis, their FRED database. And I'm specifying the dates, the start date and the finish date. And we can just run that. And the data just is introduced in, and then I can take a look at our data. And then I'll convert these. This is M2. So if, for instance, I want to take a look at the M2 data here, we could just say M2 and run that, take a look, just quick eyeball it. And you can see it's, it's in the thousands here, right? So running from a few hundred. And if I take a look then at the CPI, it's an index, right? It's not a consumer, it's not inflation, it's the index, right? So we have to take a percentage change in order to get calculate inflation rate. Okay, so down below I do that. In fact, using again the pandas, I have this % change, which will convert the M2 into its percentage change, and I create a new object in Python here, M2% change and CPI % change, and we can take a look at that. And we can see here, this is month-on-month increase in money supply. And there is a fairly significant, that's a 1% increase per month. And when we look, so that's fairly, significant, and we probably get a sense of that here, right? So 2019, 2020, there was stimulus in the US as a result of COVID-19. That has resulted in higher money supply, but we're not seeing it manifest really in terms of inflation. Let's take a look at inflation, CPI. So CPI % change, just run. And when we look at the inflation rates, yeah, it's still relatively under control. Now, what's going on perhaps is that although consumer prices are not increasing very dramatically, asset prices have. If you look at Apple, if you look at any of the stock price indices, the value of properties, housing, all have increased fairly dramatically. So perhaps that's where we're getting that uptick in asset price inflation as opposed to consumer price inflation. And also the arrival of the Bitcoins, the Ethereums, and so on. This type of ramping up in the value of those assets is suggestive that there is M2, the increase in M2 perhaps is manifesting itself not so much through the consumer prices, but through asset prices. Okay, so I'm going to leave that for another day's work. Basically, what I want to do is just show a little bit of what we're capable of doing here in the Python Google Colab environment. I'm going to run just a very basic regression, and I don't recommend that you use this in your dissertation. You may use the techniques, but not the econometric approach here. So that's a health warning. I just want to establish some basic graphing, right, of the index, right? So I'm going to run this again. And then what I've done is I've dropped so we're looking at M2 and then looking at CPI, and then we take the percentage change, and then I've graphed the percentage change here. And again, you can see money supply actually fell very dramatically initially in 2000 and the consumer prices dropped very dramatically 2006 7. So this is monthly inflation, right? We don't have annual inflation. The figures are monthly. That's 2%, almost 2% there, 2007, 8, 9, that type of period, 2007, 8 probably. And money supply was increasing, right? So again, that's a little bit, out of whack with what we had spelled out before here: money supply, velocity, price, and the quantity theory. But obviously what's going on, there was a shock and there was an economic recession, and governments responded by the quantitative easing, especially in the US. You had asset purchases that were really enormous. There were forms of bailout for the banks, but the money supply did massively increase, but we did have a drop off in the inflation rate. So you see, this relationship is not completely mechanistic, right? There's subtleties here. And that's probably what Luke was pointing out in 2010. Okay, so anyway, I'm going to give it a go. I'm going to import in statsmodel, which is one of the libraries for doing this kind of, you can also use sklearn, right, for running regression data analysis. Statsmodel gives you kind of an output, looks more like, the format of the output looks a little bit more like R or kind of stata type output. So we'll use that here. And we're going to say that the consumer price index percentage change, so inflation is the endogenous and money supply is exogenous. So this is going to cause this, right? And then we run an OLS and we produce a fit, and then we get a summary of the output. And for the entire period, we do get, now read these numbers with a pinch of salt, because I haven't taken into account the serial correlation, which is going to inflate the t-stats and r-squared, and I haven't taken into account stationarity, co-integration. I haven't addressed any non-normality issues in terms of the OLS assumptions. So it's just a basic bog standard regression, and I haven't even included constant. So M2 here is positive, and we're saying an increase in M2 produces an increase in inflation. But again, we can see there are breaches of that during different periods where, especially here, we saw a very sharp increase in money supply and not really any dramatic increase in inflation. And we see a very dramatic increase in money supply here, no real dramatic increase in inflation. Okay, so overall, over the full term, yes, it would appear the quantity theory idea holds, but like so many things, comes with many caveats. The main trust here, the main motivation for introducing this quantity theory of money in the Google Colab is more about what we can do with the technology using pandas. Using the Panda reader, we can just scrape the data off directly from the Federal Reserve of St. Louis rather than go directly to the series and try to download into a CSV file and bring into our environment. The PDR gets underscore underlined data Fred. That's a very powerful function that allows us to pull in directly the data. We can eyeball the data. We saw that. And again, that's very powerful. M2, just read it in, and we can say, look, that's our data. We can say, look, we want to look at the more recent observations, tail 20, run that, and that'll give us the last 20 observations in terms of the money supply CPI. So the pandas here are very powerful for allowing us to look at our data, and also we can we can easily graph here and so on. So that's basically the functionality that we have here, and we've tried to set up what is the basic relationship between the two. But of course, it's this is highly fraught, and don't attempt to put this into your dissertation and pass it off as credible work. Lots of things haven't been addressed here, but you can see how basically the stats model can be brought into your environment, right? And then how you can call up an OLS and run an OLS where you denominate or you designate an endogenous variable. So that's the dependent variable, and exogenous is the independent variable. And then we performed an OLS regression and without a constant, right? Must be said. Okay, I'm going to leave it there.